So this question's asking me to say what the actual transformations were that took my original function here to my mapped or image function. Only problem is the right-hand sides of both of these don't look in the same format. They're not written as the same standard functions. You know, they're not written both as a hyperbola that's like 1 over x, because the second one's got a +1 sitting at the end there. So my first step is to make them both have the same standard function on the right-hand side. In this case, it's a hyperbola. And I'm going to need to rearrange. Now, I don't have to rearrange both. I can actually just rearrange the image function. So let me write down the original first of all for you. It's just y equals 1 on 3 minus x. Now let's write down the transformed or image function, y prime equals 4 on x plus 1. Whoops. And that's the thing about it, that it's not a +1 on the bottom, it's a separate +1, and that makes it a little bit, but not too much, annoying. I'm going to have to rearrange this image function to make it look in the same format, same standard function on the right-hand side. Don't mind what happens with the y's on the left. So, and there's a prime, that's my image function. So I'm going to minus 1 off y prime minus 1 equals 4 on x prime. Now, I probably could work from there, but it would be even easier since this original function has a 1 on the top. It's a 1 on some type of x, which can be transformed. I'm going to divide by 4 to make it have just 1 on x prime. Now the right-hand side of the original function and the right-hand side of my transformed function, which has been rearranged, are both in the same format. And that's going to be now possible to work out what the steps of transformation were. So what I can do is I can take this y here and say, well, it's turned into y prime minus 1 over 4. So y has become y prime minus 1 over 4, which means I need to rearrange that to figure out what y prime is. So for y equals y prime minus 1, so 4y plus 1 equals y prime. So I'm just going to write that up here. Y prime, I just found, is 4y plus 1. So what I did to get y prime is I have multiplied the y by 4 and then added 1. We can say then that this is a vertical dilation by a factor of 4, like we've times the y by 4, and then a vertical translation up 1 unit. Or you can say that it's dilated by a factor of 4 from the x-axis, if you're talking vertical. So I'll write it that way. Dilated from the x-axis by a factor of 4. And so that's the first thing that's happened vertically. And the second thing is translated 1 unit up. All right, so that's what's happened vertically. And now I can consider what's happened horizontally by saying, well, that 1 on 3 minus x has become this here. So clearly this x prime on the bottom is got from going 3 minus x. So I don't need to do any working out there because it's already directly written there that how did you get x prime? Well, first I would say you it says minus x, so that means that's a reflection in the y-axis. And then we've got plus 3 happening here. So that's a translation 3 units to the right. So those 4 dot points are what has happened to turn our original into our mapped function. And you could describe them in a different order. You could have said the 2 light blue ones first and then the 2 green ones second. But what it's best to do, you describe your dilation first and then your translation second there. That's what seems to have happened in both cases. And we've got our sequence of transformations there is our dot points.